Next installment of the Manufacturing Hub podcast. Today, we're going to be joined by a very special guest, G. Brooks-Zac. In just a moment, we're going to give her the floor to introduce themselves. But that being said, we don't have Dave with us this week. Once again, Dave is a little bit sick. He's on a trip in Munich. He's going to be flying back tomorrow. So hopefully next week he's going to be doing well. If you can send him a message to wish him well, I would definitely appreciate it. That being said, we're going to have a really interesting conversation continuing on the theme of industrial systems integrators. And I think nobody else would be a better guest to sort of close off the month. Off stream, we had a bit of a conversation because we've exchanged emails in the past, and I've certainly learned from your knowledge. You have a YouTube channel, you have a presence on your website. So I think we're going to discuss those topics as well. But you've been a very solid contributor into the systems integration space as we know it. But without any further
Thanks.
delay, welcome everybody back. I wanted to welcome our guest once again, G. Brooks-Zac. Welcome to the show.
Thank you.
Awesome.
Super excited to be here.
Yeah, absolutely. Thank you so much for taking the time. Before we dive into the, I want to say, more technical and industry related conversation, could you give us a little bit of a background about yourself? How did you get into industrial manufacturing? What was your career like? And ultimately, what led you to starting Outlier Automation?
Oh, yeah. That's a fun one. Well, I would say that I'm a mechanical engineer by training, and I was always interested in control systems all through school. Specifically, like wanted to apply it to like clean technology and sustainability. And I ended up going to MIT for my master's, and I actually worked not in control systems, but my thesis was in thermodynamics and optimization. So, like the math side of control systems, it's a lot of like simulation, modeling, applying that to like the theoretical aspects of thermo. So that was very in depth and fun, I guess. But I think out of that, I just realized that I really enjoyed working on like physical systems, and that's kind of the big difference of control systems versus like that simulation modeling environment. And so when I graduated from MIT, I kind of did a 180 and went into field service out of that experience. And so my first job out of school was working in water treatment, which was kind of related to my master's. And I was working on oil fields. I was like up in like Alberta. I went to like South America, things like that. And this particular system that was like very specialized for oil and gas was also highly automated. And there was a need to know PLCs, and I was like, haha, this is my chance. And I, started learning Rockwell and was supporting commissioning essentially, and then started like designing some of the systems as I was kind of getting it further into that role. And from there, I ended up going to a systems integrator and really like spread my wings in automation from that base knowledge. And why did we end up going to Outlier? So I'm the owner, but started the company with my wife, Liz. And we were kind of, she's also an engineer. And we kind of were both at the point of our careers where it made a lot of sense to, I guess we were just like doing a lot, and learned a lot about technology and business. And we were like, hey, like, we're interested in starting a business and why not do it now? And we kind of and in that year, moved across the country, had our first kid, started Outlier, and that was 2019. And it's been going well since. It's been, I think, 5 years, or this is our fifth year.
Awesome. And I guess I have a couple of questions for you, but let me maybe start in chronological order. So
Yeah.
going from I want to say a mechanical master's into controls, what was the, I guess, the transition like? Did you have to seek out a mentor? Did you have to go to some of the Rockwell courses? Like, what was the maybe the learning curve like for you at that time?
Yeah. Well, out of my master's, I actually had a lot of like computer science kind of exposure. Like, pretty much my
Okay.
entire thesis was having to write like essentially like C-based programming, running it on servers and stuff. So I had a lot of like that computing background. But then as far as like actually starting to learn PLCs, I think that's where that field service side came in, right? Like getting familiar with instrumentation, what having to measure pressures, and then like this particular water treatment technology that I worked on was a lot of like sequences, and then like, oh, someone like made made a typo in this PLC code, and like, why is this sequence not running now? So it was kind of like starting to get into a highly automated process and actually starting to monitor code. And then uh, I took some of the Rockwell courses, and then from there, it was kind of like making small changes and realizing like, don't download onto this like huge water treatment plant, right? And then like taking ownership and learning like the ins and outs of all of the aspects of layers of knowledge that you have to know in control systems.
It's very interesting, right? And so I guess like my perspective has been a bit different in the sense that I didn't learn anything about PLCs in engineering, but I guess I was very focused on electrical and sort of programming in C, C++ for embedded systems. But I guess if you were to look back and in retrospect, do you think you would have benefited to have more software oriented maybe classes or focus, or do you think the mechanical aspect is really important, right? Because let's say I have by osmosis a basic understanding of mechanical and process, I want to say, elements of manufacturing, but I wouldn't necessarily know as much as someone who did a mechanical engineering degree and then learned PLC programming. So I'm curious if you have some maybe thoughts on that.
Yeah, I think that it kind of depends on what your viewpoint is of what what things are important in control systems. So definitely like there's an element of mechanical, electrical, and programming as most people would know. But I think that what defines the difference for me is and is helpful to have the mechanical knowledge or the understanding of the process is that a control system is still like you have to understand at the core physically what's happening, and that I think in the learning of mechanical engineering is like how things move, or if the physics of it is something that I've found is very helpful. And I guess in I also as an undergrad didn't really have any exposure to like what a PLC was, even though like I was taking all the control systems courses. I think maybe now it's a little bit different because there's like recognize that there's a gap there. Um, but I would say that, like, I actually had a math minor, and I kind of wish I would have done a computer science minor instead,
Mm.
looking back, because some of the, like, just modern programming concepts that I could have learned at that point would have been helpful going on into my career.
Yeah, I would say I had to some extent like bridge those gaps for myself as well because I think at the core like software engineering is almost I don't want to say underestimated, but I think not necessarily fully understood by electrical and mechanical engineers due to the curriculums. And I
Mhm.
think there's just much more to software, I guess, creation and sort of the thinking process of designing proper software that is required than at least than I have found myself to see in some of the manufacturing plants. But anyways, that's a side a whole
We
conversation.
might get into that conversation actually, but knowing what our topics are gonna be.
Yeah. Let me ask you on the outlier side, right? So I think you mentioned that you essentially made the decision to pick up everything and sort of move with that decision. I'm assuming there must have been some trigger or some conversations around getting started. So I'm curious again, like maybe what that looked like, because I know a lot of our audience and talk to some of my peers, I want to say that ask me the question of, well, I would like to go into business. And I think people to some extent don't always understand what that really means. So I'm curious, maybe at that time, what your thoughts were, and I guess also today, reflecting back, what you were thinking.
Yeah, um, definitely, I think there's a big difference between like going out as a single person and like offering contracting services versus like planning to like start a business that is sustainable. There's like different just different things that you would have to think about, right? If you're just like a single person and you're like really like highly skilled, that's one thing. But when you have to like sustain business for 10 people and you're responsible for their salaries, that's something completely different. But like as far as the the decision, I think it was more that it was something as a life experience that my wife and I, kind of were interested in, and some of the, like, decisions that we wanted to have with our family that made a lot of sense. So, like, we were in Chicago, and we wanted to move to the California area, mostly because of family reasons, and also it kind of, like, allows you to choose your adventure. If at least it felt like that at the time, and I definitely still think that's true, but, like, there's a whole lot more that, like, when it goes to, like, sustaining your income and, like I said, the income of other people, that, like, is it just a different responsibility. But as far as, like, starting Outlier and why, I mean, I think in particular, I'm very well, we focus on advanced manufacturing, I would say, and specifically in like good design of control systems and then like implementing those designs. And uh, I, in particular, are am I don't know. I just like really like manufacturing and like the parts of it that are like really that hands on, like what I was saying with control systems. And as having like our own firm, we can like focus on that and like really be good at it. So I
I like
that's
that.
what it's been allowed us to do with Outlier.
Let me ask you, I guess, on that same like note, maybe what are some not necessarily learning points, but maybe what are some good resources for someone who's trying to understand maybe the business aspects better? And I'll start by saying, I went and did my MBA, which in retrospect I think is much more applicable towards going into a career in a larger enterprise, but obviously gave me some foundational knowledge of finance, accounting, and I think it kind of gave me a glimpse of what starting a business is, but I wouldn't necessarily say that's maybe the best way to prepare of starting a small business. So maybe what were your thoughts like at the time, and maybe are there any interesting, I guess, things that you think helped you lay that business foundation? Let's call it.
Yeah, I think that like some of my previous knowledge, I had exposure or quite a bit of exposure in like what it means to like sell a project and like approach clients. Where if you're just purely doing engineering, like you might not have ever needed to do that or thought about like, getting a contract with someone and like the types of liability that you might be involved with when you're like working on a huge machine that like are important things to think about if you're actually like running a business. um, Other aspects I would say is like, like marketing. How are you going to go find those clients, what you're going to do, and like also just like the time that's involved with that, right? So like a control systems integration firm, you're either basically selling a project and getting a certain amount in, which fairly translates to hours, or you might be like selling equipment, right? But there's to even get to that point, there's a ton of work that goes into that, right? You have to, and there's only so many hours in a day. So I feel like it's almost like if you're just one person can work 40 hours a week and be like billing all of that time, that's one thing. But then if you have to like work like 4 months to get that, that's you're not really making any money, right? And like those different aspects, like you might not think about if you're just like working at a company and being handed a project.
Yeah, I would say it's easy to fall into that trap, right? And I think without proper like business, at least exposure, or I guess like knowledge through courses, it's not that easy to navigate as a solopreneur, especially for the first time, right? And
Yeah,
I
sure.
think you said it very well. So
Yeah,
that
I would say one other resource is that we joined the Control Systems Integrator Association pretty much immediately, and that's like a great resource of to understand like what the business model is.
I guess I'm familiar with what they provide in a general sense, but if someone's not familiar with CSIA, what maybe like in a few sentences, what kind of resources or things do they provide for integrators?
Yeah, well, I would just say like it's an association of people across the country or businesses across the country that have a similar business model. So they're providing, feedback on best practices, different resources through membership, and like the control. The I think they just changed the name, so I apologize if anyone's listening. But it used to be called the Executive Conference is coming up, and so it's like a place to go and talk to your peers or people or different types of companies that are different scales. We're pretty small, but there's systems integration companies that are 500 or more people that have completely different problems from a business perspective. Problems
Gotcha.
and
And
opportunities, I would say.
I'm assuming through that network you could sort of pick up the phone or reach out on the forum or whatever that looks like and sort of ask maybe for a sanity check before you either like go into a contract or take on a project and sort of like bounce ideas with these people as well, right? So it's a network of integrators in a sense.
Yeah, there's actually like different resources that you can get connected to through whether it be lawyers or marketing, a few different things that you can get access to if you're a member that can, you know, help. Yes, like I would say, sanity check that you're kind of baseline with the industry best practices.
And so I guess fast forward to today, right? So
hmm
outlier automation, could you paint us a picture, what that looks like? As I've mentioned a little bit earlier, I know you guys also produce materials, resources. So maybe what is the overview and I guess the reach of outlier automation today?
Yeah, so we're based in Fresno, California. So that's the Central Valley of California, right? Basically, right in the middle of the state, and we're adjacent to the Bay Area, Silicon Valley, and then Los Angeles, which is about 4 hours away. And I would say that at a high level, like I said, it's mostly advanced manufacturing. And what that means to me is like you're doing something that is, needs to be highly flexible, changing rapidly, doing different types of manufacturing processes. But also, like, there's an element of digital transformation in there that really applies to any type of like industrial manufacturing company, right? And so I kind of think of it as we are providing, project-based work, engineering services to either consult to how to do manufacturing or industrial processes better by using automation or digital tools. And then we'll also then like implement that. So, it could be a machine that's like super old and this machine is very critical to that, that facility, but it needs to be migrated. And then like what should we do to migrate it? What new servos do we need? And then like should there be, better data handling? Should this be sent to the cloud? Things like that. That's kind of like the aspects that we think about and work in different parts with specific to a customer. I don't think we particularly focus on, or I would say we don't particularly focus on a industrial specialization, like a specific industry, kind of by design, because my personal philosophy is that different industries are doing different types of specializations or investments in automation at different points because of like market reasons, right? Like a good example that I always think of is like automotive has regulations to retain data because of safety reasons that are traced to like a VIN number, right? So
Mhm.
they have been having to track that data for a long time, right? Same thing with
Sure.
medical, but like other industries are just it wasn't like a requirement to like keep their business going to track that data, but now they're realizing that that's a good idea for other for other reasons. But like you could use concepts from automotive in like just a general assembly process even though like it's not the same industry. So I would say that we actually try to get broad exposure across industries if we can.
Interesting. And I guess to segue us into, I want to say, some of the questions that we outlined, I'm very curious. So I've not had, I want to say, firsthand exposure to, let's call it the Silicon Valley aspects of industrial automation. I think I've mentioned this off stream. I had an interview but I decided it wasn't the right move for my family at the time. But I'm very curious, like what's the because I think we all see Silicon Valley as being this sort of like pinnacle of innovation and high tech. I'm wondering if that also permeates into the industrial aspects. Like, have you found that to be very similar, where engineers are very well accepting of cutting edge technology, or is it similar to the rest of the U.S.? I'm curious what your maybe perspective is in terms of similarities and also differences, but also opportunities when it comes to working with those types of companies.
Yeah, I mean, I would say that like pretty much everyone has some type of technical background or like appreciation of technology and what it can do, which is really exciting, right? Like we're getting exposed to all of the new things that are happening. Um, but at the same time, there's kind of like uh, I would say like a lot of understanding in like just like modern programming practices. Like it's kind of a given that you know what like a repository is, for example. Um, but, you know, doing, like, automation and, like, making a machine move or, like, understanding how a servo works is something very different, right? It's kind of like what we were talking about, with, like, the mechanical versus, like, computer science degree, right? Like, having a mechanical degree, like, you will understand, like, what it actually takes to, like, physically move something, and, like, just doing that and only knowing software doesn't necessarily translate. And like the protocols that are used, for example, in like communication protocols, why is an industrial communication protocol exist? Someone that like doesn't have any exposure to industrial automation wouldn't know that or know what to choose, for example. So that's where like we kind of come in is like uh, kind of aiding that skill set where it either isn't there in like a startup or it's like already like a huge established company and like their entire like standardized control system team is like kind of allocated elsewhere and we can kind of help augment that team.
Gotcha. But so if I understand, there's still a bit, I guess, like of not necessarily pressure. I think pressure is the wrong word, but there's an expectation of higher like software competency when it comes to even like industrial automation software. Is that like kind of the sense that I'm getting?
Yeah, I would say that's true. So I would say that like knowing like, different types of like databases or SQL integrations or like just like general programming best practices is kind of like an expectation and already a known. But then like as we kind of all know, there's like a gap there of like what industrial automation is capable of at this point for good reasons. I think actually, it's not that I don't particularly think that it's behind. It's more like the reasons why the technology is as it is. But it's not going to be able to. It is purpose built. A PLC is purpose built to be reliable and fast, and it's not going to do the same thing as like a Linux server, right? And like
Right.
so, like what are the differences there, and like how do we do XYZ. Um, that's a good example. Like putting a lot of data into a cloud, um, into the cloud. Maybe you're generating like lots of data at set very small milliseconds, right? Like, how do you actually get that from the PLC all the way to the cloud? There's like, it's not just the PLC. There's a bunch of stuff in between,
Yeah.
and there's some type of architecture there that like a control system person probably needs to be involved, and someone who's like IT person needs to be involved. It's kind of like the general IT OT thing, but on hyperdrive, I would say in the Bay Area.
No, but it sounds like people are a lot more, again, like open and more receptive to those ideas, right? Because at least from my experience, and I would sit in many meetings, try to convince a manufacturer that, hey, like the cloud is safe and it's safer than your on-prem server that the guy, on third shift kind of set up. And there's a lot of these like discussions I want to say that I'm sure you can almost like shortcut with companies that understand what that truly means, and having experts in proximity is very important. But also, like for a systems integrator, I think it's really cool because you sort of like get exposed to the entire stack, right? Because again, as we talked a little bit off stream, you understand cloud, you understand the applications that can be deployed there, you understand how to the point of bringing between like different industries, but also bringing, let's say, like the apps that are in the cloud available, almost a decade ago to the general software population. I feel like in manufacturing, this is still sometimes like this, like we've discovered fire in certain facilities. Like, oh my god, like this is possible. Where like it creates like how to say, an environment for an integrator to be able to like actually use those skills and understand them and then be able to like apply them. And hopefully, again, you guys don't only have projects in the Silicon Valley, you can also reapply them, and hopefully the companies outside of there can benefit as well, that are maybe more hesitant to work with their local systems integrators because they don't have that knowledge and exposure. So I think that's really cool.
Yeah, I mean, I think there's a few things there. So, uh, for one, I would say if it's like a startup or like just a new technology, right? Let's say we're like establishing a new facility. in Silicon Valley, like, it's kind of a given that you're gonna try to use everything that, like, Industry 4.0 promises, right? And so, like, those those pieces are, like, already there, like, we're already getting all of the data out of the machine. It's actually kind of interesting because I feel like if it's, like, specialty equipment that's coming being built for someone in the Bay Area, like maybe the programming that comes from that equipment doesn't actually have all of the data set up to stream out of that machine. And so there's like a gap there where sometimes we've been involved with, adding on to pre-built software that's coming on a machine in order to get data out or to allow it to do something else that didn't by you know enhance the robotics, enhance the data that's coming out of that machine.
Interesting. So they expect the data to be already sort of like collected. That's a base, like granted, I guess, requirement of a lot of your projects.
Yeah, well, I would say it's more like like what data do we want and like that we need to be able to get this data. So, like, I've been involved in consulting projects of like, what should we specify for this very specific machine that like, let me step back a little bit. Like, I would say that like in Silicon Valley, most of the time, there's, you know, some type of process or product that's being created that like no one has ever been never created before, right?
Mhm.
So like the general idea is that you're trying to make a proof of concept that it will work at a large scale, right?
Mhm.
um, it might actually be a product that is like built on a Raspberry Pi. Like you have like it's in a lab and there's like alligator clips everywhere and there's not like an industrial like there's no industrial components being used at that point, right? It is you basically have an idea that you're trying to get funding for, and then like if you're starting to get more um, money or like prove that this is going to be a good idea and that like this is a real like profitable thing that could happen, probably then at some point there's a transition of like, okay, how can we manufacture this product? And when you start to think about how can we manufacture this, then now you're going towards the industrial automation point. So once you get to that point, there's probably a like a pilot of the manufacturability of the product or like making a specialized machine to manufacture that product. And so that's kind of where we have been involved is that like proof of concept that like you can get to the next step
Mhm.
of to prove that this is a good idea.
How clear? I guess I'm assuming. I guess it's almost a rhetorical question because I think it's not very clear. But how clear are the specifications at that stage of what is required? And I guess, and how much do you have to almost, I don't want to say like whiteboard and change the specs, but how much is there of that like back and forth with the company through the process of, let's say, building out that like initial skid or pilot, if you call it that.
I mean, I would say like there are no specs necessarily.
Okay.
So like a lot of times I we've had projects where we're literally our project is to define the spec, right?
Really?
So
Well.
yeah, so like let's say you have what's a good example? Let's just say that like you have uh like a torquing operation in a battery assembly is like a common one maybe because there's a lot of companies doing that. So what should you torque this bolt to, for example? Like you could probably take like some adjacent industry of what that torquing should be, but like if you need to consider like manufacturing this at a super large scale, like maybe those this torque is not going to be good at these conditions if it's uh, I don't know. Maybe you're making a flying car, and there's companies that are literally making flying cars in Silicon Valley. Like all of those conditions of both like what the product has to be and how you would manufacture it repeatably in a large scale facility are things that like you don't necessarily know. Like you can start from someplace, but you have to prove it out. And so that's kind of where this like idea of like first, getting the data from the machine. I've seen a lot of companies where they are basically buying used equipment that's like for that specific. operation.
Mhm.
But then you're like have to modify it for like this product that you're making that can change over like very quickly as well. So you're the places where it comes back to automation is like one, we have to modify equipment that like might be some random vendor, right? Like we don't know anything about the programming. We have to allow this programming to change, you know, maybe in a month or 2 months. Let's say that they come up with some new idea, want to try to run it. Well, if it's the programming is written like everything is hard coded, then that's like us reprogramming everything. So you have to think about like how can we approach this if we know it's going to change. Like how much effort would you spend in programming to make it flexible versus just like making it work right now. I feel like I just went in a whole roundabout, but there's like a ton of stuff to consider if you are like you don't actually know what the specifications are, but you're building a machine to make the specifications.
Gotcha. And that's look, it's super interesting because I never thought there were such environments because for me it's always been, there's a process engineer, there's a mechanical engineer, and typically the process engineer would sort of define what we're looking to do from like a process standpoint, and then you just adopt, like you essentially create the controls in order to make that happen. And obviously for me it's always been, on the programming and hardware side, and there's a mechanical counterpart who's going to take care of all the sort of like the mechanical aspects. But again, I assume there's a lot of variability, but I didn't think it was to that extent. And so I think that's super interesting, but also probably very stressful and sort of a lot of like time crunches, I would assume.
Yeah, I mean, I would say it's like we're not defining all these things, right? Like we are kind of augmenting a team of whoever our customers are to provide the skill set that's like essentially the industrial automation side. So like, hey, we want to do this from a mechanical perspective. Like, can will it be a problem in the control system part? And then we're essentially like helping guide those decisions and then like helping implement them too for like whatever like we decide to do. Um, I would say that kind of going back to the stressful part. I mean, I think that in general, like the expectation to change quickly is there, right? So in like a startup environment, or like a company that's sort of new, I would say that it's kind of like the idea of a lot of people say like fail fast, right? So you want to kind of prove a proof of concept that it's going to be a good product, and if it's not going to be good, then you want to know that upfront. And so, like, things can change really quickly. Like, what if they lose their funding now? Like, all of the, this project is ending like right now, right? Or like, you know, outside, right? If it's an R&D type environment, then like they might all of a sudden realize that like this isn't going to work. So then, from the automation side, we're working on this machine. We need to change course pretty quickly.
Uh, Well, that's like another, I guess, like aspect I haven't even considered because at this, like on one side, you have to be like very optimistic, I guess, about what's going to be built, but on the other side, you have this like uncertainty whether or not it's going to not even work out, and sometimes not even because of your fault, just because of the process specs or whoever designed whatever this needs to look like. And so it puts you in a very interesting, I guess, like negotiating position as well. Um, yep.
Yeah, I would say that like when we're doing projects where it's specifically in like an R&D type thing or a proof of concept thing, like we're kind of shaping our project like specifically for that. But I kind of like if I'm or our company is kind of like consulting on like whether this is a good idea within like control systems or like, kind of helping identify the risks. I kind of like think about it like what a lawyer would do, right? Like if someone's asking me like can a control system do this or like what are the risks involved, it's kind of like a lawyer knows the law very well and like understands the details of like what the risk could be to like make a decision when it is like related to the law. For me, it's like, okay, I know control systems very well, and like, yeah, you could do this, but it might not work out because you're pushing the scan time of the PLC, or like this motor cannot actually do that thing. Like you could do this, but it might not work and therefore it will delay the project, right? Or it will like cost a lot more to do it this way later. And so we're kind of giving the guidelines of um, how much effort will take versus like upfront versus, will it delay the project? Will it cost more money? Will it not even work from a technological perspective?
Interesting. So I'm assuming, and I guess I'm curious what your kind of like process has been with some of these projects. Are there maybe like phases where you split, like, hey, like we want to achieve this, and how well have we hit this target, and then you kind of decide what phase two is going to look like, phase three, phase four, like as an example. And I'm assuming everything can technically be done, right? If there's enough like funding, is if there's enough resources, but there must be like a cost prohibitive question that nobody probably wants to discuss but has to be discussed. So is it split into phases? Is there like a different or better approach for, I guess, like your conversations, or in a general sense that you've maybe noticed or seen?
Yeah, I would say overall, we typically try to like have like some milestone that we're working towards. So if we're kind of like always continuously talking with our customers to be open communication of like, hey, we were supposed to do, you know, get this robot working by this time. But like actually something else has come up where like we can't work on the robot now because the bin that the robot needs to actually like uh have access to, that bin like doesn't work, for example. So are you okay with changing course and like this, because we're doing this, like we're not gonna be able to work on the robot now? And like if a customer, and I would say this is general like good practice anyways, right? This probably doesn't have to do with like an R&D, but like if you're able to engage your customers and have open communication in any project, right? Having that relationship is critical, and I think it's even more critical when there's unknowns, is that like getting buy-in regularly that like this is a course of action that makes sense. And I actually was like a couple weeks ago there was a book recommendation given to me about like how risk is kind of like playing like poker. You want to like incrementally make the right choice and like build your stack, right? If you come look back at it and have additional information later, you might like think it was a bad choice, but like you really should be evaluating like with what you knew at the time, was that a good decision, and like keep making those good decisions, whether it be with a technical aspect or like affecting an entire business, right?
Mhm.
um, you don't know at some point and you're trying to find out the things you don't know and then like eliminate those risks if you can.
Gotcha. Let me ask you, I guess, a slightly different question. And so, in terms of maybe opportunities for systems integrators in that market, what are some of the critical, maybe like points? I think like it's very clear that you need to be very versatile and adaptable. But is there, I guess, like, do you see other integrators trying to enter those types of contracts and then fail for whatever reason? And I guess, like, what are the opportunities for integrators there?
Hmm, that's a good question. I would say that like um, it's kind of interesting because it kind of depends on the structure of like a startup or whatever, what their strategy is. Some startups like to, you know, hire a bunch of like direct employees. Some will like not want to do that and like only have contractors. And so I would say that if there's like a big effort going on, then maybe like a bunch of contractors will be brought in, and it can be not necessarily that you're in the Bay Area. But definitely like understanding like new technologies and keeping up with like what the technologies are, which can be actually like quite a lot to do. That's probably like how you would get an in there. I mean, understanding, that's a good, I don't know, that's a good question actually. Other aspects there.
No, no, absolutely. And I guess like to maybe expand on that last point of new technologies, right? So I think we talked about maybe the software best practices as like technologies, but what about like the industrial automation like knowledge? Do they expect you to know like the latest features of, let's call it, like TIA Portal or Studio 5000, and the speeds of the drives, or is it more on the traditional software that the expectations are placed, or maybe all of it, right? Like, so I'm curious how you think about upskilling maybe not only yourself but also like the team and whoever's going to be working on the project?
Yeah, I would that's a good question. So, I would say that like the need to understand like baseline like core automation is like very real, right? Because just like understanding how to translate um between different like industrial protocols, for example. Like I was thinking about like an example of I had to figure out if I could pull data from a mass spectrometer that was pulled from a lab onto like a manufacturing line. And I've like literally like never like touched a mass spectrometer before that, right? And like
That sounds,
thinking
I
through
don't even
like,
know what that
okay,
is.
it's to like analyze gases and stuff, like what the
Gotcha.
materials are. But like first of all, I had to like think about like what is the um like how is this recording data, where is it recording data, and I ended up just like having a laptop connected to it, and then it's just like sitting on a CSV file. Then I have to think about like, okay, how do I get that data into like the SCADA system, and like where is that data going to live? And like the first question went in my head was like, how is this communicating at all, right? Like a lot of like research type stuff is going to be like RS-232 still and like a serial connection. And like that's not, I mean, there's of course there's like being used in industrial automation, but like we would think of it as like typically, real time polling and like over Ethernet or something, and like a continuous like connection to a instrumentation. And so like I feel like what's possible in industrial automation or typical in industrial automation versus, you know, um, test environments versus vehicle environments, like all of these things, like those separations and the whys are like a super important part of that still, of like how it's typically set up in industrial automation, like what signals to even expect of like 4 to 20 milliamps, and like how you get that into a controller is definitely a need.
Interesting. So I guess you have to like reverse engineer almost the system to figure out what signals it produces and then how to tie that back into like an industrial automation type of a environment. Huh.
Exactly, yeah. That's what I had to end up doing, was figuring out how to actually get that back to, like, the control system.
Gotcha. Yeah, and I've certainly not worked on many of projects of that nature, so I could see how it's unique and different. But it must be interesting again, like from the processes that you're describing, because at the end of the day, a lot of these companies are pushing the envelope in one, I guess, vertical or another. So it must be like extremely valuable, like from their standpoint, to figure out how to get this instrumentation back into something that makes a bit more sense and maybe is a bit easier. Also, I find that the industrial space provides tools that are more standardized, right? Because I'm sure you could pull that data into like a database and build a website and like a UI over, like all kinds of different applications. But I think in industrial automation, like once you have the data, there's a lot of tools that are almost not necessarily plug and play. I think that's a very um, basic way of saying it, but it's more streamlined and there's like more guardrails because you can put up an HMI and it will like if you get the data into it, then you can pretty much display it versus reinventing the wheel in like an application and such.
Yeah, I mean, what I tend to think of it is, like, when do you need what in from a data perspective, like, of course, you can get data, like, a million different ways now. It's just like, how do you wanna skin the cat? But, like, if you need the data to be there every day, 24 hours a day at a super high frequency, maybe, like that's where you're starting to think about like what are the tools in industrial automation versus just like a Raspberry Pi or like a custom built um I don't know, C sharp program, for example.
Yeah. And let me ask you, I guess, this, and I don't want to get into like a brand debate, right? But I think that we all know sort of the big players, I want to say North America, the big players in Europe. Is there like, do you see a similar approach? And I know, again, this is open information that let's say Tesla is standardized on Siemens, for example, which is, again, I don't know for what reason, let's say, but they must have had a reason someone very smart has selected the platform. But I'm curious in the projects more like on the R&D side that you're seeing, are people open to all sorts of platforms? Is there still vendor lock? Is there like maybe a bias towards a specific set of like platforms? Like, I'm curious what you're seeing from your experience.
Yeah, I mean, I would say that people are open to any brand. Personally try to stay agnostic and recommend what is the best technology for that particular thing, and that can be more than just like the technology to consider at that point, right? But I would say that some of like the favorites, like Ignition, like is like kind of a given. Kind of like geographically where inductive automation is very close to
Hmm.
the
All
Bay
right,
Area
interesting.
as well anyways. But like kind of going back to what we were talking about, like with databases, data integration with Ignition, you can literally do whatever you want, and like what if you can think of it, you can probably do it, right? And some of the technology stack that is in IT or like general programming practices, that is all kind of built into Ignition by default because of the way it was thought of. But, you know, from other aspects, like Siemens and Beckhoff are also like very popular. I think Siemens is just pushing the envelope. They have a partnership with NVIDIA on AI, and like AI is huge in in startup land. And Beckoff is also like, it's based on a PC, and you can do a ton of custom programming on it that is not just the PLC part. And so it kind of makes a lot of sense in a lot of aspects, so especially when you're doing test environments, um, where you can integrate with other types of like that mass spectrometer, right? For example, like there was already a PC there, and there was needing to have instrumentation, and so it kind of makes sense, and people like that. But I would say that like pretty much anything where you're like any vendor that is pushing the concepts forward of, modularity, like object oriented programming, is looking at like really looking at what industry 4.0 is in, AR, AI, adaptive robotics. If they are thinking ahead and actually making those concepts happen in reality, like probably new technology in startup land is going to be like adopting that sooner.
I guess when you talk to people in those spaces, are they surprised in general when you tell them, the industrial space is only now getting tooling for, test-driven development? We're only now getting some, I want to say, repository implementations. We're only now sort of understanding or starting to understand what are some of the software concepts. I don't know, like inheritance, polymorphism. I don't think we're even there yet, but like, are they surprised when you show them maybe even like the IDEs and sort of explain to them what goes into this?
um yes, I mean, I would say that like if it's someone that like is a software person, they probably don't realize like w- the limitations of what you can do on a PLC versus like a full computer. And for me though, I mean, I do think that like PLCs are going to get more towards, or maybe not even exist as a hardware thing, right? Like there's a virtual PC, or like that compute power being someplace else is like already like a concept that is very like real and being executed on Siemens, for example. Um, but I think that like as far as the real-time requirements of needing to have like millisecond decisions and doing it super super reliably, like those I guess considerations in like an automation environment are not the same as what you would consider in an IT environment. Like even the time scale is very different, right? Like you have
Yep.
to be in a PLC, you have to make a decision in a millisecond or less if you're like working on a motion control, for example. And like in an IT thing, like you can send a message off and like no one can ever someone might not respond and you don't care, right? Like those are two completely different things, and like the investment of that is part of the reason why I think that it is that state. But at the same time, like I do think like manufacturing in general is behind in the US and like needs to keep coming up with the technology.
Yeah, and that's a really good point. This is a slight side note. I had a conversation with a colleague in software also, and he told me that they're building a website that is real time. And I asked him like, "Well, what do you mean by real time?" Right? Because obviously we know what that means on the OT side. He told me 30-second update times, right? So I'm like, yeah, like that's very different scales. I think when people ask for real time, like now controllers are pushing like microseconds, right? So it's a very different time scale because ultimately, real time is not zero. For those that are maybe not have not worked in those types of environments, so there has to be a definition. But let me
Yeah.
ask you. You made a comment on AI, right? And I wasn't, I guess, like we had not prepared to have that conversation, but like I'm curious again, like are you seeing anything interesting? And I know there's a lot of advancements from like a software standpoint. I think again there was that AI software engineer that was released either last week or like 2 weeks ago. But I'm curious maybe on the industrial automation side, right? And I've seen the demos of like the co-pilots that I'm not sure if they're fully released or are being released, but I'm curious if you're seeing any like tangible opportunities, or maybe if you've incorporated anything into like workflows out at Outlier that makes sense, maybe that you're capable of sharing.
Yeah, that's a good question. So I think it depends what if you're talking about AI in general, like business case use versus like AI in manufacturing. Because I do think that like the maturity of AI is different, kind of like for the same reasons that I was talking about with like an IT thing can just like go off into nowhere and never be responded to. Like, right, like AI in like a marketing case, like it can be wrong and people probably don't care that much, right? Like they just kind of laugh. But in like an industrial application, if it's wrong, like you actually have like very real um, things that could happen, right? Like if an AI robot goes to the wrong place, you might like damage or hurt someone. So I think that the maturity of AI is definitely like going to need to be upped in order to like probably be realistic for widespread use, but it kind of goes back to like the idea of like if you have a ton of money and need to solve a huge problem, like you probably can use that AI in manufacturing and industry. And I know that there's like Nvidia is working on it with Siemens as well, which I mentioned before. But I think really the obvious use cases for AI in manufacturing or industrial automation are vision. You have a ton of data right there where there's very mature vision models, and it makes a lot of sense and is a lot better than standard camera vision models that we had. Like most, I would say most industrial automation vision vendors probably have some type of AI or machine learning type product at this point. Uh, where I feel like it gets a little bit difficult is where you're starting to actually use it in a PLC or like control decision. Um, One, because you have to have like so much data to make that decision. Um, and two, kind of getting into like the regulatory issues. Like I know that, like, if you're thinking about using AI in, like, medical or pharma or food regulation, right? Like, if it was based on, like, a statistical analysis and it you don't actually know that that was, like, the right decision or not, and, like, in the pharmaceuticals, for example, like, you have to validate what the control algorithm is, but by definition, AI and ML is changing, so it's kind of like, how do we use it, and, like, how do we come up with the right tools to be appropriate for that industry?
Right. And to be honest with you, I was thinking of maybe even simpler things that I would like for us to get to as an industry. And like maybe one of them is, let's say you have a schematic of a fairly simple skid, or maybe like a robot cell that moves boxes from point A to point B. And then by describing, I guess, the function, maybe you could at least give you a starting point of a ladder logic routine or whatever it is, if it's structured text or anything of that nature. And then maybe like also like working backwards, if you just give it a program, maybe it explains sort of in words for someone who may not be a control systems engineer. And then also, I guess the next step would be if you have the data of how that system functions, and then it throws an error, right, like at a specific rung, which I, as a control systems engineer, need to like go back and like trace like, well, where does that trigger? And then like I go to another routine and another routine, and like try and figure out all those links. I would think the AI should be capable of, at the very least, narrow down like what has triggered. And I think it should almost be like a given at this point, because I think again in software you can do tests and you can like pinpoint and step through code, and in PLCs that's not a thing. But I guess I was looking even at those types of scenarios because I think it facilitates the link from someone who, or I guess like it reduces the learning curve of control systems, and even going to a new site that you're unfamiliar with, right? At
I
least
think
in the
that's a
beginning.
great point that I didn't really think about when you first asked the question, but for sure I've definitely heard a lot of people talking about, how to compile the documentation of a facility and make it searchable. So like more from like a troubleshooting perspective or even knowing like what is in the documentation. That makes a lot of sense. And I think I haven't used it myself, but I'm pretty sure Beckhoff also um, released a tool for their programming. I'm probably not saying this correctly, but there's tools that make sense actually, and I think probably in Beckhoff it's a little bit easier because you have mostly using structured text as opposed to a graphical language.
Yeah, and I'll need to do more research, right? Because I think everyone's sort of trying to figure out how it's going to change, I want to say, like our jobs and our careers. I think we've seen sort of the repercussions on the software engineering market, but I think in controls it's still very unclear, whether or not it's even going to be able to be better than, let's say, control systems engineer, and like what is it really going to bring. And I think everyone has some ideas, everyone has some thoughts, but I'm not sure if like any of us, or at least I'll talk for myself. I've not tested it. Like I've not gone into ChatGPT and asked, like, can you generate me like a few rungs or a few lines of structured text code, and how accurate or how good it really is. And I'm assuming there's a breaking point, right? I'm sure I can tell it like, well, create me a motor starter with like two push buttons, and I'm sure, or I guess I'm confident that it'll be able to spit out like a single rung. But as soon as I make it a bit more complex, I'm assuming there's going to be a limit. But I think it would be interesting to figure out if that's like someone needs to build that study. Anyways, that's my
Yeah,
point.
actually, my thought on that is that probably the industry needs to become a lot more open in sharing code to be able to have that data available, right? So, like, for example, I'm pretty sure that, like, Microsoft, like, the Copilot stuff is working on examples of base code that makes sense, right? Like, if you're there's, like, a million websites that need, like, data entry, for example, and there's, like, a clear, example of, like, how you would do that and how you would learn like, teach an AI model based on that. But, like, even thinking about, like, okay, I don't know, uh, a a beer brewing skid, what code would that look like, right? Like, is that even available on open source? No, it's not. So, like, I think probably one prob maybe people will become more open in that. I think that one's maybe hard because there's a lot of, like, proprietary and intellectual property that goes into the code that we write.
Mhm.
Um, but, maybe we can start to get more more open in smaller pieces, right? Like maybe just like what is the right code to control a motor baseline of like a general way that we all agree to write that code. And I think that's a general past even getting to the AI to AI and like a general thing that people can debate whether that's a good thing for our industry and should be where our industry is going.
I look, I think I've had this conversation even like 5 years ago with some of my colleagues, and I think nothing has really changed. I don't know if it really will. I think it's really hard because let's say if you approach, I'm assuming there's like three top brewing companies that have designed their proprietary skids that are probably password protected under NDAs. What would incentivize them to share, let's say, code on a third party platform that they would necessarily just not have control over? But I also agree that I think that's the right approach, but I don't know how to make it worth their while from like a business standpoint, right? I can see why they would be reluctant and they would keep that as a proprietary process. So
Yeah, I think it might be similar to how like a lot of the industrial communication protocols have become like open, right? Like they were started as vendor specific Ethernet IP, Profinet, EtherCAT, and then became open because like essentially they want other companies to adopt that protocol and make hardware devices on that. So like a similar use case of like why the code being open might make sense. And I think a lot of like the just main, you know, Java or like Oracle being spun off into an open platform, kind of something similar happened.
Yeah, and I think maybe if there's enough, I'm thinking similar to the Linux Foundation or the Cloud Native, like the CNCF Foundation. I think if there's enough, maybe pressure of a nonprofit that starts on that route, then it might happen. But I am not sure that in the current environment there's enough, not necessarily pressure, but I guess that there's enough incentive, right, for them to go that route. And I don't know who that party would be. It could be one of the associations, right? So they might have some, how to say it, like not necessarily power, but I guess some, how do you say, like some negotiation strength to incentivize them, like, hey, like maybe within, not necessarily completely open source, but within, let's say, this network, make your software available. Maybe that's sort of the next step, but again, I'm not sure we will get there. Any final thoughts on that, on that side?
I
Because
think that's a challenging one.
yeah, that's a debate, right? That could happen in our lifetime, hopefully, but I, like I said, I'm skeptical. Um, Let me ask you, I guess, like your thoughts on some of the new tools, right? So as you mentioned, you have to pretty much like upskill yourself and the company, and some of the, I want to say, some more clearer practices than others. So I'm curious, what are your perspectives maybe on utilizing, we've talked about AI a little bit, but AR, VR also plays some role, and it's not necessarily building stuff for AR, VR stuff, but like being applied in industrial automation, same as like IoT in the industry 4.0. What are some of the other ones I want to talk about? The
Digital twin maybe is one
digital
that
twin, exactly,
yeah.
yes, simulation and digital twin. Maybe thoughts on those?
Yeah, I mean, well, one thing I think that I didn't mention earlier that I think is interesting to about the Bay Area is that those concepts are being kind of thought of as a product in the Bay Area, and like I've seen where startup companies there are going outward to other manufacturing applications, saying like, "Hey, we have this idea for a robot that can, I don't know, adapt in this particular way. I don't know, a movement, for
Okay.
example, for in automotive, let's say." And I've actually gotten calls where it's like, "Do you think this is a good idea?" Right? So I think it's interesting to think that like it's actually happening in reverse, where I'm going with industrial automation more towards the Bay Area, but the Bay Area is coming up with AI
Mhm.
techniques that can be applied to manufacturing and trying to like pull up the technology. But as far as like, not that area where it's already like kind of a given that like you're going to use these industry 4.0 concepts, I think that like if it's a legacy company or a company that, has had not a lot of reason to invest in digital transformation yet, I think it kind of makes sense to think about, what is required to actually make your company compete and stay competitive as like overall the technology is coming up. Like I would think that like in 100 years, some most companies, not if not all companies, are going to be using all these concepts of whatever we come up with to actually get to industry 5.0 or whatever, right? Like we're not using steam engines anymore for a reason. But like how you get there and stay competitive as a company is like at what level you're going to invest. And it kind of like I would think about it as, you know, where can you make incremental change and prove that this is a good idea? So, for example, um, like being able to digitally track the orders that you fulfill in a manual assembly line. So, um, we we work with Tulip. Tulip is like a
Mhm.
basically like a software app, kind of like an MES application where you can create your own apps that can digitally track, work orders or assembly instructions. And it's their philosophy is to basically start small, make a small pilot project, prove that you can get value out of like eliminating paper, for example, from like not handing someone a piece of paper and like, how many did you make today? Okay, here, let me go write this on a whiteboard. But
Mhm.
like actually making an app that's very specific to that manufacturing process and then building out from there. And I think that concept applies a lot to any type of these industry 4.0 things. If you say that like you're going to be like going from writing everything down and then like the next year going to be completely digitally transformed, that's probably impossible and completely overwhelming, not to mention disruptive to that business, right? So it's like there has to be a champion that like wants to do this and like bring everyone on culturally to try out robotics, try out these things and like incrementally improve their business. And that doesn't necessarily mean technology. It means like being a good business overall and using these tools to help you.
And I really like that point, right? Because I think I've certainly seen my fair share of unsuccessful implementations where the goal was simply too ambitious, right? And the company was not going through those incremental steps, and they would essentially be defining that last step as the next step, and so it would just be way too difficult for them to bridge that gap for better or for worse, right? Because I think it's important to recognize that you can probably look at the white papers that Tesla has released and how they run their factory. But if you're a small, let's call it manufacturer in the middle of the US and you're comparing yourself to them, it becomes very difficult to sort of like manage those expectations. So I really like that point. I think that makes a lot of sense.
I think a lot of it has to do with like the fact that it existed before or not. So for example, like anything like Tesla was had the opportunity to start from nothing, right?
Mhm.
That's a lot different than having a company that's been around for 100 years with 300 people that have been doing their job for 30 years, right? And in a very specific way. And it's there is a very clear human factor that goes into operations, right? And I actually just like wrote an article about this in Automation World about like bringing the workforce along in these initiatives is what's going to make it be successful and also unlock other opportunities, right? Like we all know that there's a huge skills gap, right? And people that are going to work in modern factories need to understand technology as well, and like everyone needs to buy into it in order to make it successful as a whole.
Yeah, absolutely. And I'll make a note to find the article so we can put it in the description if anyone's listening to this after the fact or is listening to this in audio form only. We'll make sure to have that link in the description. I do want to be respectful of your time. I know we can talk about these topics for a very long time, probably the entire evening. That being said, if I can shift us to the closing questions. So first of all, predict the future, right? Like, what are your thoughts maybe on a 3 to 5 year horizon? Doesn't have to be in industrial automation specifically, but manufacturing in a general sense. Where do you see us in that time frame?
Yeah, I mean, I think I'm excited that like there's becoming a lot of attention to manufacturing in general and that there's a need to become better at it again. And I think like even from like a federal level, there's investments in like battery production, clean tech semiconductors, and I think like there's a focus on it now and I'm excited for that and I have confidence that like we're going to rise to the occasion and, solve some of these big problems that are coming up.
I hope so. And look, my perspective is similar. I think historically, the if you read the books, the U.S. was almost founded on the concept of manufacturing and production. Through the ages. I guess this is my personal opinion. I think like we've lost that maybe in the recent years slash a couple of decades, and I think now it's sort of there's more pressure for us to bring this back to the U.S. Whether it is to like reshoring, bringing new technology, taking that like I guess the next leap of being the technological force. So I think it's certainly positive, but I think there's still a lot of work to be done. So really appreciate that. Career advice. So maybe again, Open floor. Like, what are your thoughts on someone just getting started in automation? Someone maybe looking to start their own company. Someone maybe looking to engage in the West Coast area on some projects where you're maybe best career advice.
Hmm. Um, I think my advice is not so much technical. Definitely, like if it's a technical area, like be good at asking questions and figuring out the core why of something happening. Kind of going back to the ability to look at any technology and kind of figure out what's going on is from a base level is kind of like my specialization or our group specialization of not being familiar with the technology and now like, oh, now I have to do something with this, right? Like understanding the fundamentals of, what's physically going on. Like this must be able to communicate from point A to point B. How is it doing that? And really getting good at asking the right questions to yourself and to others in order to build confidence in yourself is like critical to be good at technology. Never just like copying and pasting something and then not thinking about like why am I doing this is an important one. But in a non-technical sense, um, whether it be like starting out your career or starting a business, I would definitely say like always be kind to the people that are around you and to yourself. Um, I think there's been so many times where well, first of all, like, you never know who's watching you, right? Like, there's been times in my life where someone has come back to me, 2 or 3 years later and said like, "Hey, I saw you stand up for this thing," right? And that put I remember that, and, like, it really made a difference in my life, and anything that comes back to like your career, your business, or just like life in general is about like treating people well and like respecting other people. And like when you do that, like think good things come back to you.
I really like that message. Thank you so much. Book or content recommendation. I already see that you have one of my favorite books, but the one that I always recommend to some potential founders. But any, like, I guess, pieces of content, G. Like,
Yeah. So I think this has to do with like the what we were talking about at the beginning with the like starting a business. I would say that if you are considering starting a business or like think that you're a good controls engineer and now you're going to become a systems integrator, to read the E-Myth Revisited. Um, I think the main thing is that it talks about like what makes a small business run well versus fail. And the reality is that a lot of small businesses like don't make it past the first couple of years, and this kind of addresses that. But the main takeaway that got out of it is that it talks about what it's like to be a technician, which is the kind of the terminology they use in the book of, um, you know, like you're a good controls engineer and you're good, and therefore you think that you can run a business based on it. And there's different aspects that go into it about being a manager or an entrepreneur and like having the inspiration to like actually make a product or make a real thing that runs by itself. A business is you're not supposed to be the person doing all the work. A business is that like you enable a organization to do the work, and it talks a lot about that.
super important book. I could not have again like said it better. I think that even I wish that I would have read it before I ventured out on my own
I
because
agree.
because because it's a lot of like lessons that you how to say it, like I think we all want to be this like one like solopreneur that does everything, but I think it opens your eyes on there's maybe a better way if you really want to do better technical work, right? Because I think the first thing that people think about is I'm going to work on better projects, I'm going to be able to select my projects, which is great, but there's a whole other layer of things you've not been doing before that now falls on your plate. And I think people just I guess to your earlier point, going into business should be have as much understanding of what that really means before you make that decision is how I would maybe summarize it.
Yes. I think when I started my business, I was like, "Oh, I only need to work like, less than 40 hours a week to like make like a good salary, right?" And I think like in reality, like I am fully dedicated to my business at all hours of the day. and I take care of my kids and my family, and that's like about all that there's time for. And I think like this book in particular has some really funny anecdotes where I'm just like, oh man, that is really what it's like. And I don't think you realize that until you're in the deep. But I would say another point of advice there is that if you don't if you think about it too much, you probably won't try, and there's always you must try in order to accomplish something, and so there's worth in doing that as well.
Yeah, that's a good point also. Let me ask, I guess, like before the last question, but on the content side still.
Mhm.
Um, I know you guys. I mentioned this earlier. You guys publish on YouTube. You also publish on your own like blog, and we'll have those links as well. But could you give us maybe a pitch like on the content side? Is there like and again, I've used some of your articles to set up servers and license managers, but maybe if you were to pitch what you guys cover in terms of like content for Outlier, what does that look like?
Yeah, I mean, I would say that I kind of have a little bit of a passion of teaching other people, and I think that there's like, I mean, you with Solus that there's not a lot of like good content to really explain to people like how to use tools in a way that is not just like a super basic like do you know go online with the PLC, download the PLC. It's like more, there's a lot more to it of like why you would want to do something. And that's the types of things that I personally try to cover on our YouTube or on our blog of just like different cases of like real use cases of backing up a PLC values after you commission an entire machine. How do you do that on like on Siemens or Becca, for example? And I try to really think through like what are the reasons that you would do something in a software and explain that to help people understand uh, how to craft code and architect code.
And I, to be honest with you, and going back maybe to our earlier points, I almost wish that OEMs did a better job. And I know there's probably, if you dig far enough, there's going to be some data sheet or some like manual that maybe explains some of the concepts. But I think there's an opportunity, again, like for us, at least as an industry, to create some of these materials. So again, I've gone through your stuff personally, so I know it's of good quality. And there's a lot of very high end, I want to say, topics. Because again, to your point, I think there's more documentation on sort of the fundamentals, but there's very little on how to get things done once you get to a very advanced level. And I think that's there's almost non-existent except for you guys. So definitely
I
appreciate
appreciate
that.
that. Thank you.
How can our listeners help and who should reach out to you, right? So this is again could be, are you guys hiring? Are you guys looking for more contacts, clients? Are you looking for maybe contractors that could help you deal with some of the work? What is your pitch to the audience?
um, Well, first of all, I would say that like I genuinely believe that like open connections to anyone is always something that I'm open to. You never know when connections are important, but it's like how can I add value versus how can they add value to me, right? It's always like a back and forth and helping people. And so if you want to reach out, please do so. In particular, subscribe to our YouTube channel. It's at Outlier Automation. We also just recently did a collaboration with Siemens to create the Unified Academy, which is a free course and platform for learning WinCC Unified PC. And that just got released. So if you want to learn about that platform or just HMIs and SCADA in general, some of that content is there. You can go to siemens.com/unified academy, and there's a promo code UA Outlier 24 to get 100 free hours of cloud use on WinCC Unified PC.
I will do my best to find all those links. And again, if you're listening to this, we will publish them.
Yeah, thank
Um,
you. I would say one other thing too is that in general, like we're always open, would love to have more clients and advanced manufacturing, interested in digital transformation. If you're in the Bay Area, please connect. And we work nationally too. So um, if you think we can help, I would love to.
Awesome. And let me ask you, I guess, like one last impromptu question. I know you'll be at some of the conferences this year. Are you able to share, I guess, what your plans are? I'll be at Automate in May, but I'm curious maybe which conferences you're planning to attend in our space.
That's a good question. I am not as good at, like, planning. I'm not sure if I would do Automate or not, and kind of leaving that one up in the air. But I will be at Realize Live, which is in May for Siemens, which is basically a digital transformation and like high technology conference in different areas. And so that will be pretty cool to learn some of the other aspects besides just industrial automation, and covers like manufacturing tools, modeling, digital twins, and stuff like that. So I'm pretty excited for that one.
It looks like it is in May 13 to 16 for those who are listening and or watching in
Yeah, it's in
Las
Las
Vegas.
Vegas. Yeah.
Perfect. Awesome. Thank you so much. Really appreciate the time. I think there's a lot of topics we've covered, but also there's a lot of interesting, I think, like things that we maybe have to think about as an industry, and that's like AI. Maybe try and figure out a way to publish some of the software. I think someone needs to really step up and do it. But anyways, that's some open-ended questions that I think we left hopefully for the community or maybe for us to consider. But thank you so much. Really appreciate it.
Yeah, thanks for having me.
Thank you
Talk
everyone
to
for watching.